Continuing in section 2.5, we're going to do a really amazing topic called cryptography, which is coding, decoding, encoding, whatever you want to say. And here we go. Comes from the Greek word kryptos, which means hidden. Very interesting fact. I also came from the planet Krypton, but it shows how much I know. Now, let's look at this. So here's a basic code. Notice that I'm looking at the letters of the alphabet. A is 1, B is 2, C is 3, so on and so forth. A space is just 0. This is a very simple code. And this is what kids do like in school when they want to pass notes. But it's really not great for encoding because, typically, for example, the letter E is used more often, I think the most often, than the letter T. So if you would see a message coded like this, you'll notice a lot of 5s and a lot of 20s. M is a pretty M, like Mary is a pretty, NN is pretty popular. Those are like 13 and 14. So coding this way is not, that ain't going to cut it. But we're going to start with this. We're going to start with this code. We're going to assign just a numeric value for each number. Just make it simple. Again, there's zillions of codes you can do. We're going to start very simple here. Now, what we're going to do now is we're going to take a message, meet me Monday. So it's meet space me space Monday. And here's what you're going to do. So first, we're going to do the simple thing. We're going to take the letters that correspond to the letter in the alphabet. E is the 5th letter, T is the 20th letter, M is the 13th letter, 0 is the spaces, and so on and so forth. That's what we're going to do first. Now we're not done. This is just the first step. Okay. So next, what we're going to do is, by the way, cryptography is a huge topic now with all this internet, cyber encryption and all this kind of stuff. It's a huge area for people to go into now. Anyway, just mentioning that. So now to encode a message, here's what we're going to do. We're going to take an n by n matrix, and we're going to obtain a coded of uncoded message and obtain a coded message. So let me say what I'm saying. Now, if you notice, we had these little, we're grouping these in groups of 3. So these are all 1 by 3 matrices. So we want a 3 by 3 because of the 3 here, because we want a 3 by 3. And we're going to do it as follows. So we're going to pick a matrix A, which is invertible. How it's invertible? How do we know it's invertible? It is, okay. Because we did it already. We know it's we didn't do it in class, but it is. And I'm going to show you soon in this video. You're going to see as we how we show it's invertible. Anyway, here's what we do. We take our matrix A, and this is just a random nice matrix that's encoded, that's invertible. That's very important. And I know this matrix, so I am the encoder. I am encoding it. So I start with the 1355, as you recall, that was MEE, and 20 was T, 0 is a space, and so on and so forth. And I'm multiplying the matrix, multiplying this 1 by 3 matrix by a 3 by 3 matrix, and the result is you get another 1 by 3 matrix. Now, what's going to happen here is that I'm going to basically take all these guys and lay them out, and that's going to be my coded message. However, if you notice, 5 is E, and this next 5 is E. But now, the first E got turned into a negative 26. The second E got turned into a positive 21. 2 completely different numbers. So you see, in fact, here the space is a negative 53, and the next thing, the space is negative 23. So the idea of figuring out matrices based on frequency of use, that ain't going to happen here. Another thing is, we didn't quite get it this time. Sometimes you'll even find two of the same numbers in which represent different letters. Now, we didn't get it in this case. We got it close to it because we have positive 23 and negative 23. Negative 23 here is a space, and positive 23 over here is 25, which is the letter Y. By the way, why did I put a space at the end? Because this is 4 is D, 1 is A, and 25 is Y. What do we need the 0 for? Well, once I'm doing groups of 3, I just have to fill out the so this 77 basically represents that 0, which is not even relevant to, to us. But that's life in the big city. Now, what's going to happen is I have now encoded this message. So what's going to happen is that I'm going to lay out what I had here. Let me just see here. I'm going to lay out these. I'm going to lay out these same guys I had here. 13, negative 26, 21, da 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 da. You see negative 24, 23, 27, and all this lines up. But then to make it a little bit harder, I'm going to take off the brackets. Why? Because brackets tell me that it's a 3 by 3. You don't have to do it a 3 by 3. We could have done it. We could have done 2 by 2, 4 by 4. We could have done anything we wanted. But once you take the brackets off, then you don't know, was this encoded? Assuming you even know it was encoded with matrices, you don't know if we use a 2 by 2 matrix or a 3 by 3 or whatever, because I just have a string of numbers here. And now, voila, this is now encoded, and it's encoded in a much, 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 much stronger way than you would have encoded it had you just done what they did in elementary school or high school when you pass notes to each other. Because in my day, that's what we did. We passed notes. Now I guess kids could text each other and stuff like that. I don't know. It's a whole different world. But now, what do you do when you get this message? So I am the spy out in the field. I'm the, and I just sent this message in, or whatever. I sent this message. Now you receive this message. So what do? Well, I know the matrix that I used, and you also know the matrix that I used. Excuse me. You also know the matrix that I used. So we both have to know that. But the enemy does not know the matrix that we used, whether it's the whoever it is that we're trying to hide from. And what we're going to do is we're going to find the inverse of this matrix to decode this message. This is the message that you just received from me. Doesn't make any sense because it got matrixized. And you know that this, by the way, this matrix, they often refer to this as the key. You get it. And what we're going to do is we're going to use Gaussian elimination, and you're going to make an AI, and then do your row operation so you have an A inverse. And here, -1, -10, -8, that's my inverse matrix. And what I'm going to do now is I'm going to take the message, the coded message that I got. I'm going to group it into groups of 3, and then I'm going to multiply them by the inverse matrix. And when I do that, look what's going to happen here. So the first 3 letters become 1355, which is MEE. And now this is now T space M. And when I multiply by the inverse matrix, I'm going to get the original message back. And then I just use my simple, corresponding letters in the alphabet, and pow. And here we go. And now this sequence, which I got, now this is my answer. I could remove the brackets at this point. I don't really need the brackets anymore. And now I just, very simple, 13 is M, 5 is E, 5 is E, and so on and so forth. And there is my message. And by the way, I'm showing this video, but you don't have to meet me Monday. We're fine. We're good here. But the point is that I gave you a much more powerfully encoded message, and it was very simple for you to decode it by using the inverse matrix. But again, for this to work, we both have to know that same matrix. That's the thing, and that's a secret. That will be a company secret to know that secret message. And that, my friend, is how matrix encryption works. Like I say, encryption is a huge, huge field. There are many, many, many other types of encryption and more complicated and this and that. But I just wanted to give you a basic idea of how the matrix encryption works, because it's pretty awesome.